Previously, we have covered different models that were given for the benzene structure, and this way we have covered everything related to the structure of benzene. And in this session, we are going to start a new topic, which is on aromaticity and Huckel's rule. So benzene and its derivatives were referred to as aromatic compounds. The term was based on the word aroma. Aroma means having smell. So that is why benzene and its derivatives, which were found to have characteristic smell, were termed as the aromatic compounds. But calling these compounds aromatic simply because these have characteristic smell is not sufficient. Because aromaticity is a big phenomena, it is a complex phenomena which is based on increased stability. This means whenever the compound is aromatic, we are going to see that there is increased stability with this compound. As you have also seen in case of benzene, that benzene does not give typical reactions that any alkene would give. That means benzene is more stable as compared to some normal alkenes because of the reason that benzene is aromatic. So this means aromaticity is not limited to having pleasant smell. Instead, it provides stability to the molecule, and that is the reason we are going to study this topic in detail. There was a notion that any compound which looks like benzene can be called as aromatic, and this notion is not true. There are many compounds which does not look like benzene, and these are called aromatic. Like the two examples we are going to see now, these things are not in fact molecules. These are ions because these have charges on them. So these are not molecule, but these are ions, and these ions does not look any way similar to benzene, but these ions are aromatic. So that means there was more towards how to figure out that which of the molecules are aromatic and which are not, and we have to cover the topic of aromaticity. So let us begin with the definition of aromaticity, which is stated as that aromaticity is a property of conjugated cycloalkenes. Cycloalkenes means anything which is cyclic and which have double bond inside it. So these are the molecules which possess aromaticity, that the molecule should be cyclic and there should be double bond inside it. And usually it is seen that these are the molecules which possess some extra stability, which is because of delocalization of its pi-pi orbitals. Now you have encountered this term delocalization. Local means anything which is of one particular place. Anything which is restricted to one particular place is called local. The D prefix means removal. So anything which is not local is delocal. So delocalization of electrons means that electrons are not restricted to one place and these are moving. Like we have seen in case of benzene, that the pi bonds were not restricted to one place. In fact, these were shifting their places, so there was delocalization of the pi electrons. This was the more correct form, the hybrid form. So this means there was delocalization of electrons, and that was the reason which was providing more stability to benzene. So this is the reason that aromatic compounds possess delocalization of electrons, and that is why these are more stable. I hope you have understood the term that aromaticity does not simply means having good smell. In fact, it is a big property of conjugated cycloalkenes which have more stability with them, and this is because of delocalization of electrons. The same delocalization which we have seen in benzene would be observed in all the aromatic compounds. So this gives the molecule more stability and they does not react with different compounds that easily that any alkene would react. The term aromatic compounds is in contrast with other compounds which are called aliphatic compounds. So anything which is not aromatic can be aliphatic. So this is what it is trying to say. There can be molecules which are cyclic, but these are not going to be aromatic. Like you can see here that these are the molecules which are called aliphatic molecule, and on the bottom you can see this molecule which is cyclic, but this is not aromatic. Yes, it is cyclic, but it does not have conjugated alkenes. There are no double bonds which are part of the conjugation. So this molecule is not aromatic, simply it is aliphatic. So there are two different terms. One is aliphatic and the other is aromatic. When the hydrocarbons are taught to the chemistry students, then we classify the hydrocarbons into two different compounds. One term is aliphatic and the other is aromatic. So previously it has tried to differentiate aromatic compounds with the aliphatic compounds. One popular example of aromatic molecules is benzene. We have came here and we have covered the topic of benzene. So very good example of aromatic molecule is benzene. That is why you are being taught the topic of aromatic character in the unit of benzene, because benzene is a very good example of aromatic molecules. As you can also see that there are some other compounds which are aromatic, but they does not look like benzene as such. And these are other examples of aromatic molecules. There is one compound which is called pyridine. So benzene with one carbon replaced with nitrogen is called pyridine. If you replace two carbons of the benzene, then this molecule is called pyrimidine. And there is a 1,3 relationship between the nitrogens. So this molecule is called pyrimidine. When there is a 5-membered ring with one carbon replaced with oxygen, then this is called furan. When there is 5-membered ring with one carbon replaced with nitrogen, this is called pyrrole. And when there is 5-membered ring with two carbons replaced with nitrogen, this is called imidazole, and there is 1,3 relationship between the atoms. So this way we have covered the definition of aromaticity, we have covered different examples, and we have covered every statement that what actually aromaticity was and how this aromaticity topic is important because it provides extra stability to the molecules. And we have also came to this point that simply calling benzene and its derivatives as aromatics is not sufficient. There is more towards being aromatic, and there was a scientist which worked in this direction. His name was Erich Huckel. This is how his name is pronounced in German language because he was a German physicist, and in year 1931 he gave out different rules, different criterias to define which compound is going to be aromatic and which is not. So in total there were 4 criterias which must be followed in order for a compound to be designated as aromatic compound. Let us see all these 4 criterias one by one. Let us move to the first criteria, which is the molecule or ion must be flat or planar. What we mean with this statement is, as we have seen the molecule of benzene, we have seen that this molecule is planar. You can see the molecule from the side and it looks planar like the sheet of the, you can call it a cardboard or you can call it like the surface of the table, that it looks flat when you see it from the side view. So this property should be there that the molecule should be flat. Like our benzene molecule is flat. This is the criteria number 1. Let us move to the second criteria, that the molecule must possess orbitals which are perpendicular to the ring. That means the electrons that we are talking about, which should be delocalized, they must be in the orbitals which are perpendicular to the ring. Let us see what we mean by this. Here you are seeing the structure of benzene and its p orbitals. As we have already discussed in the molecular orbital model, that the carbon of benzene possess one p orbital each. So this means there are 6 p orbitals in the benzene, and if you see the angle between the p orbital and the plane of the ring, you will find that there is 90-degree angle between the plane of the ring and the p orbitals. So this is being called being perpendicular. Being perpendicular. So the p orbitals or any other orbital which is part of the conjugation should be perpendicular to the molecule. This was the criteria number 2. Let us move to the criteria number 3, which is that the molecule should possess the electron count of 4n plus 2. The electrons which are the part of delocalization, whether they are pi orbitals, whether they are pi electrons, or they are n electrons. We will see what n electrons are. So these electrons should be in the count of 4n plus 2. What is this 4n plus 2? Let us see. You can put different values for the n. You can put the value of n as 0, then the answer comes out to be 2. If you put the value of n as 0, then 4 into 0 plus 2, the answer will come out to be 2. If you put the value of n as 1, then the answer would come out to be 6. Isn't it? 4 into 1, 4 plus 2, the answer would come out to be 6. And if you put these different values, then a series would be formed with these numbers. Isn't it? 2, 6, 10, 14, 18 and so on. I want you to remember these numbers because these are going to be helpful in order to decide whether the molecule is aromatic or is it not aromatic or anti-aromatic, because there are two more terms like anti-aromatic and non-aromatic, and one of this term, anti-aromatic, follows 4n rule. Instead of following 4n plus 2 rule, the anti-aromatic molecules have all 3 criteria as same, and in one of the criteria they follow 4n rule. So if you do with the 4n rule and if you put different values inside it, then the answer comes out to be, if the molecule has 4 electrons or 8 electrons or 12 electrons or 16 electrons, so every even number which is missed in this particular series is the part of this series. So this would be for anti-aromatic compounds, and this is for aromatic compounds. So I want you to remember the series of numbers 2, 6, 10, 14 and 18 are the part of aromatic compounds. 4, 8, 12 and 16 is the part of anti-aromatic compounds. So this was our criteria number 3. The criteria number 4 is that the electron cloud should encompass all the atoms of the cyclic system. This means that every carbon of the ring should possess the p orbital or the any other orbital that is taking part in the conjugation, and none of the atoms should be missed. It is not acceptable that this atom is not taking part in conjugation and this atom can provide the electron density directly to this atom by bypassing this particular atom. This is not acceptable. Every atom of the ring should be the part of conjugation. This is the criteria number 4. So this 4n plus 2 rule is another name for Huckel's rule, and if any of the molecule which does not follows any of this criteria, then those molecules are termed as non-aromatic. So this was for this session. We have covered what aromaticity is. It's a big complex phenomena. It is not simply limited to having good smell. and there is more towards enhancing the stability, which is because of the delocalization of electrons. What are the good examples of aromatic molecules? All these were the examples, and we have covered the Huckel's rule, which was given by Erich Huckel in 1931, and there were 4 criterias that must be followed for any compound to be designated as aromatic. So that's it for this session. In the next session, we are going to cover the examples of these molecules which are aromatic and which are not aromatic. So such types of questions are asked in competitive exams. So the next session becomes very important from the competitive exam point of view. So see you in the next session.